So this is a quick demo of how this graphing application works. I was working on this with my friend. Oh well, we're still working on this, and the idea is just to show how some graphing algorithms work, just to visualize it, really. So you can place a couple of nodes. If you've watched the other videos I have, you would see stuff like this. But instead of doing this, creating the nodes and creating connections between them, we implemented a way where you can actually save your network or save your graph and also open it. So I'm just going to clear this and I will open a new file. Oh well, I'm going to open a network I had already saved. So here's a network, and we can run several algorithms on this. For instance, I can select a source and destination, and I can run BFS on this. And as you can see, it shows the shortest path from V25 to V194. Another thing you can do here, you can also run DFS and click on Start. Now, of course, this is a longer path to get to 194, but this is just the path that DFS is going to form. So basically, this is like a DFS tree with this algorithm. Something else you can do is check if the graph is bipartite or not. So when you run it, it shows you every vertex that makes the graph non-bipartite. And what that means is just basically given a set of vertices, say we have set 1, 2, 3, set 3, 4, 5, stuff like that. If they're in a different set, vertices in the same set should not point to each other. If you've taken algorithms, I'm sure you'd understand this much better. But if not, you can take a look at the code for this, and maybe you might have a little understanding of how it works. Something else you can do is also check if there's a cut vertex. So when I click on Start, it shows me all the cut vertices in this graph. Now you can see the cut vertices are labeled gray, and what that means is removal of those vertices will cause a disconnected graph. So for instance, if I remove V120, I cannot reach this vertex here. It causes a disconnected graph. So I'm just going to connect it back so we can run other tests. So another thing we can do is do a graph coloring. So I select a source, a source vertex, and then I click on Start, and see it colors the graph. And the idea of graph coloring is just basically vertices that are adjacent to each other should not have the same color. That's all this does. And this is an NP hard problem. I think NP hard or NP complete. I'm not quite sure, but basically what that means is this algorithm cannot be solved quite efficiently. And now, well, you might ask, well, it seemed like it worked on this, but the idea is given a number. Like usually the way this should work is you give me a number, say 3, and I should only color all of this in 3 different colors. But I guess that would be like another topic. And another thing you can check is if there's an Euler circle in this graph. So I can select this and check. It tells me like an Euler circle doesn't exist in this graph. And the reason that is because there are more than 2 vertices with odd degrees in this graph. Another thing we can also check is if the graph is connected or not. So you can see the graph is connected, but say if I place a node right here and I check again, it tells me the graph is not disconnected. And how we found that is just by running DFS and checking if all vertices are visited or not. And that's it for today. And I can just, I have the code on GitHub. You can look at this and maybe add more stuff to it. And we will be improving the algorithms and adding other stuff to this as well. Thank you.